Welcome to AMS Talks. I'm your special guest host, Nadia Abboud, and today I have the pleasure of sitting down with Rick Bacon, CEO at AMS, for an in-depth conversation on transformative innovation in the water industry and how it can support affordable compliance with water quality regulations. Thanks for joining me, Rick.
Great to be back here again.
Wonderful. Well, we're going to kick off this new year with an in-depth conversation. So one of the things that I always think about is we all know that water quality regulations are critical and they're necessary to protect public and environmental health. Unfortunately, these regulations come with significant costs and they contribute to greenhouse gas emissions. Some of the numbers that are being thrown around in the industry, gosh, even just in the US alone, they're talking about $1.2 trillion in terms of meeting regulatory compliance. That's a lot of zeros. And what I'm curious to know, and maybe our viewers would like to know, is how does AMS approach the development of innovations and your solutions towards monitoring or treating regulated contaminants while balancing the need for affordability and sustainability?
Well, I think we begin from the position of affordability. Whether it's regulations or companies wanting to improve their water treatment processes, there's cost involved, inevitably. And innovation that is simply going to do something slightly better than has been done in the past is not going to be good enough. And so unless we can reduce considerably costs, and what do I mean by costs? It's the lifetime cost. It's not just the cost of putting that capital equipment in, it's then the next 20 years of cost. How can we reduce that really significantly? And the other part of cost is the environmental impact, because any new piece of water treatment equipment, industrial or municipal, is going to generate greenhouse gases inevitably. And so how do we minimize those as well? And the challenge that we first encountered was 80% more or less of the water industry, industrial water, municipal, is fixed. It's not going to change for the next 20, 30 years. It's been built. Yeah. They're not going to tear it down and put something more efficient in. So how could we introduce systems, processes, instrumentation to make that existing capital base much more efficient, more cost effective, reduce costs, reduce greenhouse gas emissions? So that was our first sort of attack on this problem of cost and affordability. And making it more affordable benefits consumers, taxpayers, ratepayers, and shareholders of industrial companies. And then once we've done that, and in that process, we see how inefficient existing technologies are.
Can you give me an example of that and how that came across while you were monitoring technologies?
Sure. So Chrome 6, which most people will think of as the Erin Brockovich story, there's been attempts to reduce the levels of hexavalent chrome in people's water. It's a carcinogen. It needs to be reduced. But you mentioned, some big numbers with lots of zeros. For regulating for chrome had that implication. It was going to cost communities, big and small, rich and poor, huge number of dollars. And the existing technology, based on existing technologies, which in themselves had significant greenhouse gas emissions. So we came at it with a radically different approach, and we've actually secured our first contract now for treating for that contaminant, which plagues people's groundwater supplies here in California, 500 communities.
Now, what is that different approach that you had come at it with?
Well, without going into too much of the chemistry, we actually generate on site a chemical reagent that then is applied to the water system, and it's totally scalable from big to small, very small footprint, very limited greenhouse gas emissions compared to alternative technologies, fully automated.
But not just applicable to hexavalent chromium removal, it's applicable to the removal of
a wide range of contaminants. The beauty of it is my kids gave me a Swiss army knife for Christmas. It's got lots of blades and things you can do with it. And it's a bit like our treatment technology. The platform can address a very broad range of contaminants. For example, it can destroy PFAS, which is, when you talk about millions to be spent, that's another one on the list, right? The shopping list of where do we spend taxpayers, ratepayers' money. We can monitor and modulate and protect human health from lead poisoning in a much more cost-effective way. There's a program, I don't know how many billions, to dig up service lines. Well, in the States, that's not going to happen for the next 30 years, be completed. So in the meantime, what? We need a cost-effective way of being able to protect human health whilst that program is underway. And so it all boils down to affordability. And we are very, very focused on making safe drinking water, safe industrial emissions at a much more cost-effective way than traditional technologies.
That's pretty exciting, and congratulations on that first order. I would assume that you have a few more in the pipeline hoping to come through this year based on this innovation.
Yes, well, it's one of the best available technologies for treating it. There are, I actually misspoke, there are 300 communities, 500 wells. They've all got to be sorted out within the next 3 to 4 years. So yes, we've got demonstrations and pilots and all that sort of stuff underway as we talk.
And just to go back to the PFAS, you mentioned PFAS destruction, not PFAS treatment. So could you expand on that a little bit more? Because that might be of interest to our viewers.
Yes, there's a subtle nuance. I'm so glad you picked it up. You can remove PFAS from whatever, wastewater, drinking water, or whatever, and that's fine. The question is then, what do you do with this concentrated lettuce soup? Because it's now in a much more concentrated format, having taken it out of the water. And that is a toxic waste disposal problem. And there are technologies around for destroying it, but they're horrendously expensive, and millions are being poured into destruction. But very few people, I believe, are focused on what is the cost of that. And if we don't solve that cost significantly,
We're going to have a bigger problem.
because it's just kicking the can down the road, very typical of our industry, right?
Mm-hmm.
So we are very focused, and we believe we have developed it's producing the documentation as we talk, that can absolutely destroy, take it out of the water cycle. PFAS, the long chain, short chain, all the ones that are regulated and more besides, at a fraction of the cost than both the legacy technologies that are around and some of these crazily expensive technologies that are being, millions are being pumped into to solve for this solution. And if we can do that, we are going to save the taxpayer, the ratepayer, industrialists, shareholders, you name it, a lot of money, which makes it then possible to apply these regulations, because that's the barrier, affordability.
Yeah, affordability for communities of any size. And an interesting point, though, is that you mentioned this sort of start into moving into treatment as a result of hexavalent chromium, because you had been monitoring the existing technologies at the time with your online water quality analyzers. Where do you see that the convergence of online analyzers and innovative treatments to address regulated contaminants? Will they always have to stay together, right?
Well, not traditionally. I mean, going back to where we started, you had a treatment system that just ran. It's like having a home without a thermostat. You turn the heating on and the bill is what the bill is. You bring in thermostats, you turn the heat on, you turn it off when you need it and don't need it, right? So our initial foray into instrumentation basically turned those unintelligent heating systems, water treatment systems, into intelligent ones. Use it only when you need it, save a lot of energy, etc., etc. So following that philosophy, you look at our ground treatment system we talked about earlier, it's fully integrated, fully automated, which also means that, for example, you've got wells all over the place. They don't have people to look after these things. We can manage them, control them, monitor them remotely, 24/7. And that gives you much greater security that the system is performing as it should. And it's the same for all our other treatment systems. Our philosophy is you've got to have a very good muscle treatment system with a very good brain on top of it, which tells it when to run faster, when to run slower, and detect, if you've torn the muscle and something needs to be done about it before the fish turn up dead in the river or kids are suffering from lead poisoning. The two things can belong together, need to belong together if we're going to drive efficiency and reduce greenhouse gas emissions from, additional water treatment investments.
Absolutely. And earlier you talked a little bit about the fixed assets in the industry. We have a number of water treatment facilities that are going to be around for the next 20 plus years. So while innovation or transformative innovation might be affordable and sustainable, it also has to be scalable in terms of being able, how it can sort of be from innovation to full scale. It has to also be able to fit into these facilities without creating more greenhouse gas emissions as a result of infrastructure, et cetera. So is that, how have you approached that with your technology?
Well, we've been I think in terms of approach, we've looked for the early adopters because they sort of get the story. And we focused on those processes which we know to be very energy cost intensive. Where we have case studies down the road here in California, 30–40% electricity cost savings. So we've sort of gone where the money is or where the problem is, and across a range of industries and a range of contaminants. But you're absolutely right. Just because your plant has been built 10, 20, 30 years ago, there's no reason why it cannot be made more efficient. And I'm talking about industrial as well as municipal. There's a lot of money to be saved, and there's a big dent to be made in greenhouse gas emissions. Like I say, by using the thermostat to turn the heating on and off when you need it. And that's I think that's quite a good metaphor for why instrumentation is required.
And we've talked a lot about hexavalent chromium, PFAS. Where do you see some other opportunities for innovation in the water industry going forward, being able to apply this methodology of sustainability, affordability?
Well, we only talked about, I think, 3 gizmos in my Swiss Army knife, and we've actually got about, I don't know, 10, 20. So we know we have applications in oil field produced water for removal of hydrogen sulfide, potentially recovery of valuable metals, treatment of multiple waste streams from the semiconductor industry. Lots of millions of dollars involved in that. And given the investments going into the semiconductor industry and its effluent waste streams, which are pretty complicated, anything we can do there, and we've already got evidence that we can have a significant impact, is somewhere else. So I think municipal is very important, safe drinking water is very important, but there's huge opportunity for us in the industrial sector, given the nature of our chemistries and what we can achieve with these very advanced technologies that will bring competitive benefits to very important pieces of the US economy.
Well, when you mentioned your first contract of hexavalent chromium, I still don't want to overlook the fact that that's a significant achievement, given the fact that typically in the water industry, it's about 12 to 15 years to bring a technology into market. And from my understanding, you haven't been at it that long. So with that, well done. I know it's not just you, it's sort of the rest of the team that you have there with you at AMS, but it's really comes forward across as just this commitment to developing cost-effective, affordable solutions. And I guess you set the bar high so that everyone else in the industry can take a similar approach, where it's not just about the profitability and developing something and innovating, but how can you do it smarter and more affordable while maintaining environmental and public health protection. So any last comments you'd like to share? If we're looking ahead on the horizon, this horizon that's behind me, what's your hope for the water treatment industry?
Well, I think that it's started to become more open to innovation. We as a company need to convince the intermediates that we work with consulting engineers. They are in many cases guardians of clients, and we need to share with them the benefits of this technology, because if they carry on prescribing traditional technologies, we won't have an impact. We work very hard at that. But I actually think that there was something you said, which was about, it's not just me, and it's not just me. The reason we've done this in 7 years, which, as you rightly point out, is sort of faster than the average, is that there is an incredible team here, of a multidisciplinary team who work incredible hours with incredible commitment across the country to make this happen. I don't know if a much bigger company could have done it in the way we've done it. We definitely sort of break some.
Yeah, you have you have the ability to have a nimbleness that doesn't exist elsewhere.
Yeah, and we don't follow process too closely, which is a failing and a weak, a strength. But we're very, 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 very committed to the mission, because we can see the benefits when we get it right. I mean, this hexavalent chrome thing is going to give a relatively underserved community safe drinking water
At a very low cost compared to any other technology. Yeah.
Very low cost. But it will also be at a very low cost for big communities, because at the end of the day, it's still a consumer at the tap, whether it's underserved or well-served community. Everyone deserves access to it. And if we can make it more affordable, if we can make industrial cleanup more affordable, then everyone benefits. And we need to be judged by, are we improving the affordability of water, regulation, qualities, etc. That's the thing we need to be marked against.
Yeah, so definitely transforming water technology.
That's the game.
That is the game. Well, thank you so much today, Rick, for your valuable insights, and more importantly, for the vital work that AMS is contributing to the water industry.
Great to be back with you. Thanks so much.